Okay, students, will start now. Okay. So, can you see my screen now? Okay. Can you see my screen?
Yes, sir.
Okay. Right. So, yeah, is the slide visible?
Yes, sir.
Okay. So, last class we have started, I think, velocity time graph, right? We have started velocity time graph, right? So, that is velocity time graph is velocity is plotted against the y-axis, right? And time against the x-axis. Okay. So we saw like the number of graphs we have seen. So we'll revise it one by one. The first graph, okay, that is VT graph. Okay, just a moment. Yes. Okay. So velocity time graph. Okay. So first graph is like this, and the second graph, the slope is like okay, like this. This is V, and this is T, velocity time, and the third graph is like this. Sorry. Third graph is like this, that is this way, V and T. And the fourth graph, it's like this. This is V, T. Yeah, like this. Okay, sorry. Okay, V, T. And the final fifth graph is like this, V, T, and like this. Okay, in this direction. Okay, so we have seen one by one. We'll just revise it now. So, what about the first one? What does the graph imply? What about the first graph? What does it imply? Anyone? So, what does it imply, the graph? The first graph. Come on, students, you can answer this.
Constant velocity, sir.
Very good. Constant velocity. Okay. The first one is constant velocity. Because there is a velocity value here, let's say V naught. Okay. And it is constant for the entire time interval 0 to something. Okay. Seconds. So, likewise. So, what about the second one? Second graph. First one is constant velocity. Good. What about the second graph? Look at the slope. This is the slope, right? Does it increase with time or does it decrease with time? Come on, Ma, you can tell. Do we have Jayashri here or Vishwash, Suresh? The one thing is, I cannot, today I cannot see your comments. Okay, so if you have mic, okay, you just turn your mic on and you can speak up. What of the second graph? Anything you can tell, even if it is a wrong answer, no problem.
Velocity decreases, sir.
Velocity decreases. Okay, but actually the velocity is decreasing. Okay, okay. Let's take the example of this one. Okay, let's take the example of this one separately. So this is a second graph. Okay, so that is the velocity time graph. This is the velocity and this is time. Okay, and here the curve is like this. Sorry. So the curve is like this. Okay. So just talk about the curve. Okay, this curve is curving. It curves downwards. Okay, it curves downwards. Okay. So what that means that the slope is decreasing with time. Okay, slope is decreasing with time. Okay, so you know slope, right? You know what is slope, right? Anyone? Can anyone tell me what is slope? You'd have learned in your lower classes. You have a graph here. Okay, maybe like you have 2 points. Okay, let's say this is y and this is x. Okay, so this is something like x comma y, that is x1 y1. Okay, this is something like x2 y2. Okay, how do you find the slope? Slope is, excuse me ma, the student is joining right now this moment. So welcome Disha.
Good evening, sir.
Good evening ma. So what is slope? You know what is slope? Slope is what? Slope m is equal to y2 minus y1 divided by x2 minus x1, right? Y2 minus y1 divided by x2 minus x1. Okay, so that's what happens here. Let's say if you have like 2 points here and here, this is b1 comma t1. Okay, this is b2 comma t2. So the slope of velocity time graph gives what? Anyone?
Acceleration.
Very good. The graph gives acceleration, that is nothing but v2 minus v1 by t2 minus t1. Okay, so the slope of velocity time graph gives acceleration. Okay, very good. So here in this second graph, the slope is decreasing with time or not? The slope is decreasing with time, right? Because the curve is in the downward direction. See, the curve is in the downward direction. Okay, so the slope is decreasing with time. So when the slope is decreasing with time means what? Here slope is what? Come on, slope is what? Acceleration, right? So when you get a graph like this, when you get a velocity time graph, when the curve is in the downward direction, you can say the slope is decreasing with time. Slope is decreasing with time. Okay, slope is decreasing with time. Then acceleration is decreasing with time. You understand this? When the curve is in the downward direction in velocity time graph, what we can say, the slope is decreasing with time and the acceleration is decreasing with time. You all clear with this?
Yes, sir.
Okay, so what happens to velocity? I think Auxilia, you just said velocity decreases, no?
Yes, sir.
Okay, so what happens here is, okay, I'll explain it again. So as you know, here because of this curve, you said the velocity is in decreasing. Okay, so let's say this is 0 meter per second and this is 5, this is 10. Okay, likewise. So what happens here, the velocity first it increases 5, 10. Okay, something like that. Okay, and when acceleration is decreasing, okay, when acceleration is decreasing, okay, the change in velocity decreases. When acceleration is decreasing, okay, what we have seen here, the acceleration decreases with time. So when acceleration is decreasing with time, okay, what you have to know, that change in velocity decreases with time, not velocity, not just velocity alone. You understand, Auxilia?
Yes, sir.
Okay. So I'll tell you when the velocity will decrease. Okay. I'll tell you that also. Okay.
Yes, sir.
So what about third? Any idea?
Acceleration increases, sir.
Very
Slope
good.
is
Very
also
good. Very
increasing.
good. Very good. Slope is increasing with time. Excuse me, ma. Just a moment. The student is joining now. Welcome, Shruti. Good evening.
Good evening, sir.
Yeah, we were discussing about velocity time graph, what we have seen in the last class. Okay. Right.
Yes, sir.
Yeah. So here the slope is increasing with time, right? The slope is increasing with time. Why, Auxilia? The curve is
Sir,
in
the
the
curve is up.
upward direction. Very good. So when the slope is increasing with time, what does it mean?
Acceleration increases.
Yeah, acceleration is increasing with time. Very good. So the second graph and third graph is clear for everybody.
Yes, sir.
Okay. So what about the fourth one?
Both velocity and time is simultaneously increasing.
Simultaneously increasing. Okay, who's that actually? Is it
Dhan-
Disha? Jayashriya?
Dhanlakshmi, sir.
Dhanlakshmi. Very good. So you're saying that velocity is also increasing, that is time is also increasing. Okay. I'll explain this in elaborate. Okay. So I think that it is fourth graph. Yeah, fourth graph. Okay. Here they're saying this is velocity. Okay, this is time. So what you have to incur, that is what you have to infer about this velocity time graph is that the slope is inclined. The slope is inclined at an angle to the time axis. Okay, the slope is inclined at an angle to the time axis, like this. Inclination can be like this, maybe 45 degrees. Okay, so likewise. So when this happens, okay, what you have to know is, okay, I can simply, okay, what if this is a position time graph? Then what happens? What you will say? When it is a position or displacement time graph, what you will say for this graph?
Object is uniformly moving in motion.
What you said? Uniform?
Object is uniformly moving in motion.
Yeah, uniform motion we can say. Other words? X is displacement, t is time. Now tell me.
X is equal to t.
Excuse me? No, what happens? You said you're close actually.
X is equal to t.
X is equal to t. What does it mean? That is position is equal to time or displacement is equal to time. That can never happen. See, what is uniform motion? Anyone can you define?
So object covers equal distances at equal intervals of time.
Equal distances, very good. Object or equal distances in equal intervals of time, very good. What about uniform velocity? X is displacement now. Same thing only, no? Equal displacement in equal intervals of time. Am I right or not?
Yes, sir.
Okay. So what is we can say the object is moving with the uniform velocity, no? In this graph, xt graph, or not?
Yes, sir.
Okay. We can say that it is moving with the uniform velocity. But here we have velocity time graph. So what happens here? You say equal distance for uniform motion. You say equal displacement for uniform velocity. Here what happens? is, okay,
Uniform acceleration, sir.
very good, very good. So here this velocity time graph represents what? The body is moving with uniform acceleration. There will be equal change in velocity, equal change in velocity in equal intervals of time, equal intervals of time. Okay, there will be equal change in velocity in equal intervals of time. For example, let's say this is 0, okay, 0 meter per second, 0 second, okay. Let's say I'm taking this as maybe 2 meter per second, okay. I'm taking this as 2, okay. So here what happens, sorry, so here 2 seconds. So between 0 to 2 seconds it has attained a velocity of 2 meter per second. And again at another 2 seconds it moves with a velocity of 4 meter per second, okay. So here there is equal time interval, that is 2 2. The change in velocity is equal, no, 2 meter per second here, here 2 meter per second. You understand the change in velocity between 0 to 4 meters? See, 0 to 2 seconds it moves with 2 meter per second. 2 to between 2 to 4 seconds it moves with 4 meter per second. The change in velocity is nothing but what? 0 to 2 meters, 0 to 2 meter per second, the change in velocity is nothing but 2 meter per second. And from here 2 meter per second to 4 meter per second, the change in velocity is nothing but 2 meter per second. This 2 meter per second is nothing but del v, change in velocity, not velocity, okay. So the change in velocity is equal, okay, change in velocity is equal in equal intervals of time. There is equal change in velocity in equal intervals of time. You get it?
Yes, sir.
Okay, so you guys clear with this, right? Yeah. So what about the fifth graph? As I said earlier, the direction is in this way.
So negative acceleration.
Very good. It is moving with the negative acceleration. Then Auxilia, what happens here?
Sir,
What happens here? Somebody said negative acceleration. That is correct actually. So it moves with negative acceleration. So what happens here?
in this case only velocity decreases,
Very
sir.
good. Yes, yes. The velocity is here. Maybe I'm telling like maybe 15 meter per second, and it decreases. It moves to the negative velocity, so it decreases, and comes to 0 meter per second. Okay. Yes. Hope you guys
Yes.
are clear. Yeah. Hope you guys are clear with this. So we'll move to acceleration. Okay. So acceleration is they have given a previous sum, no? That is okay. I think you would have okay. They have given acceleration for this graph, that is velocity time graph. Okay. So here they are saying that 0 to 10 seconds there was velocity increasing, okay. And 10 to 18 seconds the body moves with uniform velocity, okay. And at 18th second, actually we have seen it, 18th second brake was applied. So brake was applied, so at 20th second the car has come to rest. That's what is given here. So as you can see, from 0 to 10 seconds the body is moving with increasing velocity, and from 10 to 18 seconds, 10 to 18 seconds, it is moving with constant velocity. And here they say this velocity is nothing but 24 meter per second, okay. And here the brakes were applied, okay, brakes were applied, and the car comes to rest, okay. The car comes to rest at 20 seconds, at 20th second, we can say like that, 20th second. So you understand this graph? So you're clear with this graph? What does the graph say?
Yes, sir.
Yes,
Okay.
sir.
Yeah. Now we are going to plot, velocity, that is acceleration time graph for this graph. Okay. For this velocity time graph, we are going to construct a acceleration time graph. That is what here. Okay. First, you have to, take this time interval, that is 0 to 10. So find out the average acceleration for 0 to 10 seconds. Okay. So what is average acceleration? Del v by del t, which is nothing but v2 minus v1 divided by t2 minus t1. 0 to 10 seconds. 0 at here, the initial velocity is what? 0 meter per second. And here the final velocity, this is 10. Okay. Final velocity is 24 meter per second. So what happens here? 24 minus 0 divided by t2 is what? 10 seconds. This is t2, no? This is t2, this is t1, minus 0. So 24 divided by 10 is what? 2.4. Just a moment. 2.4 meter per second square. Just hold on a moment, ma. So it is 2.4 meter per second square. Okay, that is the average acceleration. So what about the other, this one, 10 to 18 seconds? What is the acceleration there? Come on, you can be quick, no? Am I audible, ma?
Yes, sir.
Okay. So what is the acceleration between 10 to 18 seconds? Between the time interval 10 to 18 seconds. You can quickly say. See here, from 10 to 18 seconds, it moves with what? Constant velocity. So there is no change in velocity here between 10 to 18 seconds. When there is no change in velocity means what? Acceleration becomes zero. Am I right or not? See
Yes.
here, yeah, here at 10 seconds is 24 meter per second. At 18 second, okay, 18 second also what? 24 meter per second. Now calculate, now calculate, just a moment. So now calculate this acceleration for 10 to 18 seconds. If you do here, as you have seen, at 10 seconds, the speed, that is v1, is v1 here, and it is v2 here. V1, v2 are same, right? So v2 minus v1 by t2 minus t1. V2 is what? 24 minus 24. It becomes 0 meter per second squared. So acceleration is 0 here. So what about here? They have said 18 seconds. They have actually the time interval should be 18 to 20 seconds. What happens between 18 to 20 seconds? What will be the average acceleration? Uh, you can answer from the graph also. Okay, you can answer from the graph also. This is the 18th second. Okay, till 20 seconds. So 18 to 20 seconds. What will be the average acceleration? Come on, quick, ma. We can move ahead, no? At 18 seconds, you have seen it is 24 meter per second. And at 20th second, it has come to rest. That is 0 here. That is 0 meter per second. But by the graph itself, you can say, let's see here. It is a straight line like this. Velocity time graph. Okay, it is a straight line like this. So what is that? What does it imply? Anybody in this direction?
The negative acceleration. So our answer is minus 12
Very good.
meter per
Negative.
second
Yes.
square.
Yes. Negative acceleration. Okay. So it is negative acceleration from here to here. And the answer is minus 12 meter per second squared. Okay. For now, we'll construct this acceleration time graph. So from 0 to 10 seconds, what you have found out, it is 2.4 meter per second squared. Okay. And 10 to 18 seconds, it is 0 meter per second squared. That is, we are talking about acceleration here. And from 18 to 20 seconds, okay, 18 to 20 seconds, it is minus 12 meter per second squared. Okay. Do you have any doubt in this graph? Do you have any doubts in this graph? See, you have to understand here. If you take one by one, 0 to 10 seconds, okay, 0 to 10 seconds. Tell me what. Tell me anything about the graph, velocity time graph. Just 0 to 10 seconds, like this. Vt 0 to. It's like this only, no? Yeah. Tell me about the graph. Anybody?
Acceleration increases, sir.
Yeah, acceleration is increasing. Very good. And another thing
Change in
is,
velocity increases.
yeah. That is, acceleration is increasing with time. You are right. Okay. And here then the acceleration is positive, that you have to tell. Okay, acceleration is positive. So that's what happens here. See, the acceleration is 2.4 meter per second squared, is nothing but what? Average acceleration. Okay. So here, what happens? It is not a is it a uniform acceleration, this graph? Anybody? Is this a uniform acceleration or non-uniform acceleration? This one I'm talking about, this one. This is one. Come on, ma. Whether it is a uniform acceleration or not. Come on, quickly you can tell, no? Just now we have seen.
No, sir.
No, it is not a, it's a non-uniform acceleration. Very good. It is a non-uniform acceleration. Okay. So that's what happens here. from 0 to 10. Okay, 0 to 10. Okay, 0 to 10 seconds, the acceleration is positive. Okay, and it is non-uniform. Okay, so you understand this graph from 0 to 10 seconds, the average acceleration 0 to 10 seconds what, 2.4 meter per second squared. Okay, so you understand, or else do you have any doubt why this is 4.8? Do you wonder why it is plotted, at 4.8 meter per second squared? Anyone wondering like that? Are you guys clear? See, the acceleration we have found out is 2.4 meter per second squared, but the slope, but it should be like this only, no sir. Why it is like this? It is going beyond 2.4. Anybody can give me a reason why it is beyond 2.4? This graph, the acceleration time graph gives, says that it is beyond 2. It is going beyond 2.4. Can anybody explain? Come on, you can do it, no? Anything you can tell, or else I will teach you. If you interact only, I can sense whether I can move to the other topic or not. If it is a wrong answer, I'll explain it again. If it is a right answer, we'll move ahead.
Don't know, sir.
Okay. See, yes. So what happens between 0 to 10 seconds? That is velocity time graph. It is like this, no? So what happens here? Acceleration is increasing with time, right? Here, see, this is, I'm talking about this one, 0 to 10. Okay. So here acceleration is increasing with time. Okay, this 2.4, okay, is not the final acceleration. Okay, it will go beyond 2.4. That is why we are saying it is increasing with time. You understand? It will go beyond 2.4. Okay, 2.4 is nothing but the average acceleration. Okay, it's not the final acceleration. Please understand. Okay, it is not the final acceleration. It is the average acceleration between the time interval 0 to 10 seconds. Okay, so maybe it, for example, I can say like this. Say this is 2.4. No, let's say this is 5 seconds. So 0 to 5 seconds, this is 2.4 meter per second squared. And another 5 to 10 seconds, what is it? 4.8 meter per second squared. Okay, so the acceleration is increasing. Okay, in terms of what? You understand this or not? The acceleration is increasing in terms of 2.4 meter per second squared. You understand this or not?
Yes, sir.
Okay, very good.
Yes, sir.
Yeah, so the acceleration is increasing. That's what the velocity time graph says. Okay, so the acceleration is increasing with time in terms of 2.4 meter per second squared. 2.4 meters per second squared is nothing but the average acceleration here to here. Okay, not the instantaneous acceleration. Instantaneous acceleration at the 10 seconds, you should be have an acceleration of what? 2.4 meter per second. That's not the case here. Okay, right. So what about the second one? 10 to 18. So that that is 0 meter per second squared. That is, there is no acceleration here because it moves with constant velocity. Okay. So here, what about the third one? The graph is like this. PT. Am I right or not? See, this is the graph. The graph is like this in this direction. Yes.
Yes, sir.
Yeah. So tell me, what does it imply?
Negative acceleration, sir.
Okay, then negative acceleration.
Velocity decreases, sir.
Okay. Velocity decreases, that is okay, fine. Another one. Negative acceleration. You just said negative acceleration, right? Okay. Whenever it is a straight line like this, in this direction, okay, in velocity time graph, in this direction, or like velocity time graph in this direction, okay, you should always include a word. Okay, negative constant acceleration or constant negative acceleration. You understand?
Yes, sir.
Yes. So the average acceleration here is, it's what we have found out, 12 meter per second squared. So what happens here when we apply a brake? When we apply a brake here, what happens? Just a moment. When we apply a brake at 18 seconds, okay, this minus 12 meter per second squared comes into effect. And here also the instantaneous acceleration will be minus 12 meter per second squared. So you understand, from 18 to 20, from 18 to 20, this is 20, this is 18. It is constant velocity, minus 12 meter per second square. So we can say it is a negative acceleration. The other word is called as what? Retardation. Okay, negative acceleration we can say, or retardation we can say. Okay, right. So yes, and we'll see some of the questions before we go into definite integral and indefinite integral area under the curve. Mm, we'll see some questions and we can come here. This is somewhat happened in JEE 2008. This is a JEE question. Okay. The particle shows distance time curve in this figure. The maximum instantaneous velocity of a particle is around the point. So they have given 4 points, that is A, B, C, D. At what point the velocity is maximum? That is the instantaneous velocity, or velocity at an instant is maximum. Come on, ma. At what point the velocity is maximum? They have given us yes distance. Okay. Always remember, when you say here they say yes, we can change it x also. When I say xt, the x can have, you know, it can be referred as position, displacement. I'll write like this: position, that is x. Okay, displacement, that is del x, and distance also, that is yes. These three are relatable terms. Okay, so you can think, anyway you can think of it as a position time graph, you can think of it as a displacement time graph, and you can answer.
Sir, is it C, sir?
Is it what?
C, sir?
Yes, C is the correct answer. Very good, Auxilia. C is the correct answer. So what you have to know, the body starts from rest. Okay, it picks up speed. Okay, like this. In position time graph, what we will say for this curve, for the upward curve xt graph, what we will say?
Velocity
Yeah, velocity
increases, sir.
increases with respect to time, right? The slope is increases with time, so velocity is increasing with time. So that's what happens here from A to B. Okay, from here. Okay, from this point, From this point, as you can see, it comes here like this, from A to B, it like this is A and this is B. So from this point what happens, it attains a velocity, that is, it is a straight line, no, from here, constant velocity. Okay, that is C. Now what happens, from C the graph goes like this and it meets D here. So what does this mean, CD here, that is from here, that is the curve is in the downward direction. That means what, velocity decreases with time. That's what happens, right? In xt graph, velocity decreases with time. Okay, so here the velocity starts to decrease with time, but here it has attained a maximum, it is increasing. Okay, from here it starts from rest, it increasing, that has attained a velocity here. From here, sorry, actually right here, okay, from here it is moving with constant velocity till C. Here the velocity decreases. Okay, so it has attained a maximum velocity here, until C it is there because it moves with a constant velocity. So till here the maximum velocity is retained. So the velocity is maximum at C. Okay, auxilia is right. Okay, so you understand? So others, do you understand this? How C is the point where there is maximum instantaneous velocity?
Yes, sir.
Okay, so we'll move to the next sum. So they have given the displacement time graph of a moving particle, and it was asked in the year. It is a APMT question, All India Pre-Medical Test. So now it has become what? NEET. Yeah. So there is a displacement time graph of a moving particle they have given. So like that they have given 4 points. They are asking the instantaneous velocity of the particle. Okay. At where it will be negative. You just go through this question. I'll be back in a moment. Okay. Yeah, sorry, ma. So you have found out the answer.
Is it E, sir?
E. Okay. What about others? Auxilia's answer. What about
E,
others?
sir.
What, ma?
E.
sir.
Yeah. E is the right answer. Very good. Auxilia and the other girl. Your name is
Dan Lakshmi.
Nalakshmi. Very good. E is the correct answer. So what happens here? Like this. First, the curve is like this from C to D. Sorry. C to D, right? This is C and this is D. So what happens? The curve is in the downward direction. So what we can say? Velocity is what?
Decreasing, sir.
Decreasing with time. Very good. And we can say if the curve is like this, okay, in displacement time graph, we can say the velocity is constant. Very good. But if the curve is like this, what you will say? It is moving with negative velocity. I may not. Just a moment. Hello.
Yes, sir.
Yeah. So yes. So when we have a like this straight line like this, what we can say? ST, that is XT graph. Sorry. What we can say? It is moving with what?
Negative velocity, sir.
Very good. Negative velocity. That's what happens here. This E, it is a straight line here. Okay, like this. So E is a negative velocity. Very good. Okay. So we'll see another concept called, yeah, area under curve, that you have to know. Area under the curve. So in velocity time graph, okay, velocity time graph, okay, the area under the curve, okay, the area under the curve, area under the curve represents displacement. Okay, area under the curve represents displacement. Just note this point. Okay, so that is VT graph. In VT graph, okay, VT, let's say it is moving the velocity u. Okay, so it is a straight line parallel to the time axis. Am I right? It is a straight line parallel to the time axis. Okay, it starts from 0, let's say 0 or t till t. Okay, so it is moving the velocity u, okay, till time t. Okay, so this is nothing but, see, this is nothing but the curve, that is the velocity time graph, that is, this is the curve, this is nothing but the curve. So by definition, the area under this velocity time graph, that is this one, okay, this gives displacement, that is nothing but del x. Okay, so for example, So here the velocity, that is, it is moving with the velocity u till time t. So this area gives displacement. So how to find out this? So this represents the rectangle, right? This represents a rectangle, right? So what is the area of a rectangle?
Length into breadth, sir.
Yes. And what is length here? Okay, so length here is t and into u. So ut, this is nothing but displacement. Okay, so area under the curve of area under the curve in velocity vt time graph gives what? Displacement. Okay, so you have to remember this, that the area under the curve, okay, this area under the curve represents displacement. Anything, for example, let's say this is vt graph, okay, and this is, okay, this is what the velocity is. It is moving with let's say um, yeah, constant acceleration. Okay, so like this. So here till time t. Okay, this area, this is the curve, no? This curve, this is the curve. Okay, and the area under this curve represents displacement. You understand this? Let's say this is u. Yeah, this is u or something like. So what is the area of a triangle? This is a triangle, no? So if you find the area, you find the displacement. Displacement is nothing but area of a triangle, right angle triangle. Okay, so what is the area of right angle triangle? Half into
L into B.
L into P. Very good. So if you do this, okay, if you find out this area, you get displacement. Okay, and you can find this out by through calculus also. Using calculus, you can find this out. So that is, what is velocity? That is instantaneous velocity. Dx by dt, right? Am I right or not?
Yes, sir.
Yes, okay. So just cross multiply this, that is v into dt is equal to dx. Okay. Now when you integrate it on both sides, you have come across integration. Students, are you familiar with integration? Everyone? No? Okay. So you are familiar with integration or not?
No, sir.
No. Okay. Okay. Right. So first we'll see integration, then we can come. Okay. So okay. In a school they have taught integration, no? They have completed this chapter or not? Okay, I'll just tell you a simple example. Let's say if it's x squared. Okay. If I just integrate this, integrate in terms of dx. Okay. So what will happen here is, in differentiation, what you will do, that is d by dx of x squared, what you will do, that is you will take this, that is I'll say this n. Okay, n x power n minus 1. But in integration, when I say x power n, what I have to do is x into, okay, n plus 1 divided by n plus 1, okay, plus c. So this is what is integration. Okay. So what is this C? C is nothing but constant of integration. C is nothing but what? Constant of integration. Okay. For example, if I have like x1 x2 as limits of x, okay, if I have x1 and x2, when I integrate, what I will do is x into n plus 1 divided by n plus 1, okay, to the power of x1 to x2. There we will not integrate that, there will not include c. This constant of integration will not be there, okay, and that type of integration is nothing but called as definite integral. Okay, definite integral. So when you call when you call an integration as a definite, when you call an equation as a definite integral, that limits of time will be limits of time, because we are we are dealing with motion and time and everything. So we have to, if we have integral that has a limits of time, then we call it as a definite integral. Okay, for example, this is t squared. Okay, if I integrate with t is equal to 0 and t is equal to 1, so what does it mean? T squared into 0 to 1, okay, dt. I'm integrating with respect to t. So what happens when I integrate it? T to the power of 2 plus 1 divided by what? 2 plus 1. So it becomes t cube by 3. Yeah, and the limits of time is 0 plus 1. 0 plus 1. Here we should not write what? This c should not be there. Okay, this constant of integration should not be there, because it is a definite integral, because you know the limits x and y, that is time. Okay, 0 to 1. So now what happens after you have integrated it? Now we have to substitute these values inside, that is t cube by 3. Okay, in the place of t you have to substitute 1, that is 1 cube divided by 3 minus of this value, that is in the place of t you have to substitute 0 by 3. Okay, so what happens here? 1 by 3 is the answer, right? 1 by 3. So that is definite integral, that is you have given an integral with limits of time t1 and t2, that is called as definite integral. So you understand this?
Yes, sir.
Okay,
Yes.
yeah. And on the other hand, indefinite integral, that is you will not have a t1 t2, yeah, the limits will not be specified. You'll simply have like this, like I said, x squared dx, or let's say t, for example, t squared dt. So what happens? T 2 plus 1 divided by 2 plus 1, okay, plus c, that is t cube divided by 3 plus c. This is nothing but a constant of integration. Okay, constant of integration. Okay, so you get the basic idea. So how you'd integrate?
Yes, sir.
Okay, very good.
Yes, sir.
Yeah. So here the area under the curve using the calculus. Okay. So this dt goes here, that becomes v dt, and this is dx. When you integrate on both sides, okay, when you integrate both, okay, on these sides, okay, this here will t1 to t2, they will have limits, okay, t1 to t2, because when you find out an area, let's say this is a vt curve or something, okay, or yeah, vt curve, okay. So when I no, when I just um when I want to find out this area under this curve, okay, I can only do this if I know this point, that is what? V1 t1, v2 t2. You understand? So there is a limit of time here, t1 t2. You understood? So here t1 t2 is there, okay, so you know the value of t1 and t2. okay, by formula. And here the for dx, the integral is nothing but x1 to x2. Integral is nothing but what? X1 to x2. Okay. So area under the curve of BT graph, okay, it's given by the formula, this one, that is T1 T2 V dt. This represents the area under the curve of BT graph. You understand this till now? Are you clear? So what which further happens, we keep this as such because it is nothing but area under the curve of BT graph. Okay. So area under the curve of BT graph is nothing but V dt, integral over V dt, T1 to T2. Here when you integrate dx, it becomes x to the limits x1, x2. So what this happens? This happens what? X2 minus x1. This is nothing. This is what? Area under the velocity time graph. Area under the curve of velocity time graph is equal to, when you integrate dx, it becomes x to the limits x1, x2. So what it happens? X2 minus x2, which is nothing but what? Del x. Del x is what? Displacement. Okay. And yeah, I'll write it here. See, the area under the curve, that is area under the curve of velocity time graph, gives displacement, and the area under the curve of velocity time graph can be found by the formula v into dt, integral v to dt, t1 t2 is equal to integral of dx. Actually dx becomes x to the, sorry, here there are limits of x displacements, that is x1 to x2. So x into x2 x1. So what happens when you do when you apply the limit x2 minus x1 is nothing but del x, which is equal to what? V into dt, t1 t2. So you understand this or not? This is the proof of area under the curve of velocity time graph gives displacement.
Yes, sir.
Okay. So velocity area under the velocity time graph gives what?
Displacement, sir.
Very good. And here we'll see this this question next time. They're asking this. The area under the acceleration time graph represents. They have given 4 options. Sir, how to find out this? Okay. So what is the acceleration formula? dv by dt. Am I right or not? Instantaneous acceleration.
Yes, sir.
So cross multiply it. A into dt is equal to dv. So area under the acceleration time graph means what? Integrating on both sides. So when you integrate, this is t2 with the limits of t1 to t2, t1 to t2, limits of time with a dt. This is nothing but what? This equation is what, ma? That equation represents the area under the acceleration time graph. Okay. And here the limits are that is initial velocity to final velocity into dv. When you integrate dv, it becomes v. Integration of dv becomes v2 minus v1. When you apply the limit, I'll write it here. When you apply the limit, what happens here? That is area under the acceleration time graphs, a into dt, t1 t2 is equal to v into v2 v1. When you apply the limit, what happens? v2 minus v1 is equal to del v. So area under the acceleration time graph, this is equal to del v. So what is the answer?
Change in velocities.
Very good. So are getting it how it comes?
Yes, sir.
So you guys clear with this?
Yes, sir.
Okay,
Yes, sir.
okay. Yeah. Is everyone clear? Do you have any doubts? Because we are going to close this class. If you have any doubts, please let me know. I can just explain it to you once again before you leave. Anybody for that matter. Any part of the class that you didn't understand, no problem. You just ask. So we have Jay Shri, Mrinalini, Dhanlakshmi, Shruti, Vishwas Suresh, and Xavier Teres. I think that's Auxilia.
Yes, sir.
Yeah. So Auxilia, do you have any doubts?
No, sir. It's clear, sir.
Okay. Thank you, Auxilia. You can leave the class now. Thank you. We'll meet in the tomorrow's class.
Thank you, sir.
Thank you. So what
Thank you,
about?
sir.
Thank you. Who's that? Jayashri. Jayashri, do you have any doubts?
No, sir.
Okay. You may as well leave the class. Thank you. And Mrinalini, okay, you don't have any doubts. Thank you, Mrinalini. Thank you. You
No
may
Sir,
also.
doubts,
one more
sir.
thing, sir.
Yes, yes. Who's that?
Sir, Jai Shri,
Jayashri.
sir.
Yeah, tell me, ma.
Sir, you sent that link, no, sir, email, through email.
Yes, yes, yes. Yeah.
When should we write the test, sir? Online test?
You can write whenever you want. That is up to you.
O-
It is open. Even for Vishwash, are you there? What about yes, Vishwash, Dhanlakshmi, Mrinalini. Mrinalini, I don't think she comes under that class actually. So Vishwash, Dhanlakshmi, and Jayashri. Uh, I think we have given you the link. Okay, Vishwash, I don't think you have got.
Sir, I didn't receive.
You didn't receive. Okay, okay. I'll check it. And Vishwas, you should share your mail ID and your name in the group. Okay. So they will give you a test link. Okay, test portal link. Okay. So you can take the exams. Okay. And Jayashree, it has been uploaded. Okay. You can you can write whenever you want. Then Lakshmi, I'll check it for you. Okay.
Okay, sir.
So you can take the exam whenever you
Okay,
want,
sir.
Jayashree. Okay. So I think maybe by Monday you'll be receiving the portal for chemistry and biology also. So I think the next test they will be uploading is motion a straight line after we complete this session. Okay, this class.
Okay, sir.
Okay. So yeah, thank you. See you all in the next class. Thank you.
Thank
Thank
you,
you,
sir.
sir.
Thank you. Actually, Manalini, it is actually NEET and JEE. I don't think you have opted for NEET and JEE, I guess.